Hey, Vsauce, Michael here, and I'm in Anaheim at VidCon. I hope to see some of you here because I like you guys, but I can't marry all of you. But if I did put a ring on it, what is the most precious thing you could make that ring out of? Silver, gold, platinum, those are all fine, but I want to know what is the rarest, most scarce thing on Earth that's stable and safe to wear I could make that ring out of. And I want it to be pure. I'm talking elemental. Well, luckily, I recently went to the University of Nottingham, home of periodic videos, and experimented with some elements. First things first, zinc dissolved in mercury. This stuff is awesome. It's dense, it's heavy, it's liquid metal, it's cool.
But even cooler is human urine. Thank you, Neil. Of course, I'm just kidding. This is an aqueous solution of the metal vanadium. And when we mix vanadium in with the mercury and the zinc, the mercury helps the zinc give electrons to the vanadium. And as it gains more and more electrons, it changes color. We're looking for purple. I love shaking this. It's crazy. It's like throwing me off balance. It's so heavy. Look at that. Thank you, electrons.
Those colors were beautiful, but vanadium's not that rare. I want to get something more precious. And how about precious personally? Like my dad. He's a chemical engineer who specifically works with and has a patent concerning one element: sulfur.
Of course, a fun thing to do with sulfur is to make it bark like a dog. Here's what we're going to do. We're going to take a glass tube and fill it with laughing gas, nitrous oxide. We're going to pour a little bit of water into the tube to cushion and protect the tube, and then we're going to pour in some liquid carbon disulfide. It's very volatile and will evaporate, giving us a mixture of gases inside this tube. Finally, I will light the top of the tube, causing the carbon disulfide to burn. And as it burns, the temperature and pressure in the tube will increase, causing the reaction to go faster and faster. It'll accelerate and bark. Wow. And look at all the sulfur on the sides of the tube.
That reaction was fun and cool and powerful, but we're way off track here. Even though sulfur is precious and dear to my heart, it's not that rare at all. So let's get crazy and talk about astatine. Astatine is so rare here on Earth that we don't even know what it looks like. If you were to try to get enough astatine atoms together that you could see it with your own eyes, it would instantly vaporize itself because of its radioactive heat. The fact that it's so radioactive means it wouldn't be great as a ring, so let's move on to something a little bit more standard and see where it takes us: gold.
Gold, of course, is famous for its unreactivity, which is why it's a great way to store your wealth. If you have a lot of gold laying around, the likelihood that it will combine with other elements and dissolve or rust or corrode is basically zero, with the exception of some special solutions. In particular, one discovered in the 1300s with the fancy name aqua regia. It's made out of hydrochloric acid and nitric acid, and we're about to make some right now thanks to Neil from Periodic Videos. Of course, we're using this fume cupboard because the fumes that come off the nitric acid are quite dangerous. It's the gas NO2, and if you inhale it, nitric acid forms in your lungs. So instead of doing that, let's put some gold in aqua regia. We're just going to use this ancient, priceless Egyptian relic. Let's go ahead and try this out. As the gold dissolves, what we wind up with in the evaporating dish is chloroauric acid. Auric coming from aurum, the Latin word for gold, which is why gold's symbol on the periodic table is Au.
It's really sad to watch that gold dissolve away. I wish there was a way for us to just make other things into gold. Now I know what you're thinking, Michael, that's alchemy. But alchemy is quite real. In today's particle accelerators, we can smash particles together, creating elements. At the Accelerator Collider GSI, they can create gold by smashing particles together at a rate of 2 million gold atoms every second. That's pretty cool, right? Well, as you know, atoms are incredibly small. They're so small that even though GSI can make 2 million new gold atoms every single second, were they to leave the machine on at that rate for 50 million years, they would only produce 1 gram of gold. Gold is rare and precious and expensive, but gold is 40% more common than iridium. And iridium is incredibly resilient. It doesn't dissolve in aqua regia, and it's not even attacked by molten metals or silicates at high temperature. Which is nice and stoic, but not as pretty as cerium, which reacts at high temperature to form beautiful little sparkles. As we continue our journey to discover the rarest thing on Earth to make a ring out of, we've got to discuss osmium. This stuff is so rare there's fewer than 1 part per billion in our Earth's crust. But we're not done yet. Iridium and osmium are both in the platinum family. And if you take a look at platinum, it's much more common than both iridium and osmium, but there's something neat that I think we should consider: stable isotopes. And it's one of the isotopes of platinum that will finish our story. Platinum-190. It's a stable isotope with a half-life of over 1 billion years that's non-reactive. It fits all our criteria. A ring made of the scarcest, naturally occurring, stable, non-reactive thing. So hey, it would be an awesome ring. Now you're probably wondering, Michael, why did you experiment with vanadium, sulfur, gold, and cerium? Well, here's what's interesting. Take a look at the periodic table and their symbols. Ta-da! Vsauce. And as always, thanks for watching.